Welcome everyone to your Thursday evening dose of astronomy. I'm Irene Pease with the Amateur Astronomers Association of New York. You can find us at aaa.org and you can follow us on social media, all the social media things, at AAADOTORG. That's because it's like our website, so you see. So tonight we're going to be doing kind of a tour around Jupiter. We'll start with Earth and we'll look at where Jupiter is in our night sky. I have a special guest co-host, which I'm excited to be introducing in a little bit, Jana Grcevich, who's the Columbia outreach coordinator. So if you've been to some of the Columbia lectures, some of their astronomy outreach programs, you may have seen or heard of her. So tonight we're using these two programs. As usual, we're using OpenSpace, which you can download for free. It's freeware at OpenSpaceProject.com. And we're going to start off using some Stellarium from Stellarium.org. So I'll go ahead and pop on over to our Stellarium for just a view. Just a view of the evening sky. And I thought I had, oh, right. I knew that. A little bit of a glitch there. All right, so here's now, and you'll notice it's really bright. It's still really bright. We have the summer solstice this weekend. That's on Saturday, right smack after Juneteenth. So I hope you'll have great plans for that. But just looking around, we'll go ahead and have to make it a little bit later. So from 8, 9, 10 p.m. And again, we're kind of looking towards the south. If we look over towards the southeast, I don't see Jupiter yet. So again, pretty late. If you wait a few weeks, then Jupiter will be coming up earlier in the evening. So you can either stay up late tonight into the wee hours of the morning, or you can just wait a few weeks. It'll be great either way. So tonight, Jupiter will be rising. And actually, I want to kind of rewind this back to just a little bit after it's above the horizon. And I'm going to need a special effect here just so I can follow it better. So you can tell it's rising a little bit east of southeast, but it'll be the bright spot. So it won't have a label in your real sky. That's okay. If you're out, it'll be the really bright thing, the brightest thing in that part of the sky. So I want to go ahead and you're going to hold your breaths for a minute while I turn off the atmosphere, because the atmosphere causes like light to bend and do interesting things that I don't want to deal with right now. Cool thing about Jupiter, it is my very favorite planet to observe. So I was excited when Jana said she wanted to talk about Jupiter tonight. If you watch it like just for a few hours, right? So we're going to take a look at it now. So this would be, well, not now, but at 10:37, right? So around 10:30, 10:40 tonight, through binoculars or a small telescope, you can see the relative positions of all the moons. Let me turn some of this off here, and I'll just pause time so we can not deal with that. Pausing. Yeah, let's pause. So you can see the relative positions of the moons. And if you catch it just as it's rising, it'll be really blurry because it'll be on the horizon. But if you happen to have like a huge telescope, you can even see the red spot. So that's pretty neat. It moves relatively quickly. So if I kind of center on Jupiter and just move through time a little bit for a few minutes. Wow. See, Jupiter is spinning pretty fast. And so the red spot, it'll come and go. It'll come and go every few hours, but it's definitely moving. So go ahead and just make a note here of how close Ganymede and Europa appear in this kind of line. So the Galilean moons, the bright moons, those are always going to be kind of in a line as viewed from Earth. But even if you notice kind of where they are now, and then we'll zoom back out here, and fast forward 2 hours, and I'll see if I can find Jupiter again. Remember I said it's supposed to be the bright thing, so really easy, right? Okay, yeah, there's Jupiter again. So let's zoom back in and see how those moons are doing. So when I did this earlier, it looked like they had moved a bit. So usually you can tell just over the course of a couple hours Slight changes in the relative positions of the moons. Ganymede's a little slower, but when I looked earlier, like it did look like it had moved a little closer. I don't know if I was going forward or backward in time, but you can tell a slightly different change in the position. So that's kind of fun. So watching the moons kind of go around, and here I'll turn some atmosphere back on for you. There's some atmosphere so you can breathe again. So watching the moons go around, kind of shifting from side to side, and also just seeing that red spot come and go is a lot of fun. So check out Jupiter either just with your eye. Again, it's a really bright thing. It'll be high in the south throughout the summer, so we'll see that again and again. But if you want to try to catch it later this evening, again, it's going to be rising pretty late. But for any night owls out there, you can go out and check that out. So if you can see it tonight or later in the week, go for it. That's all I really wanted to go over in the sky for this week. I think that's enough for one week, because I did want to go ahead and introduce our guest. So I'm gonna bring up Jana. So Jana, if you want to turn on your video and say hi to everyone.
Hello, everyone. Glad to be here.
And I'm gonna bring us over to OpenSpace. So I don't know if there's anything else you want to share about what you do when you're not on YouTube. Anything exciting?
Yes. So I'm the outreach coordinator for Columbia University's astronomy department. So we run events and now live streams. So we also do live stream kind of planetarium shows. If you're interested, just Google Columbia Astronomy Outreach and you should be able to find us. And I'm very excited to talk about my second favorite planet, Jupiter. My first favorite is Saturn, I'll admit it. But I know, but Jupiter is fantastic, of course, because of all of its moons. So that's what we're going to focus on today. So here we're, where are we now? We're looking at the Earth, just a beautiful crescent Earth. So we're going to start out at home and we're going to zoom out and get a picture of our larger solar system, of course, which is where Jupiter is. You can see Earth's orbit right there coming out, and Earth's moon, its single moon, its orbit, and you'll see the solar system start to kind of take form. So we have the sun, we have the inner planets, which are more closely spaced, and the first of the outer planets after the inner planet Mars, we have the outer planet Jupiter. Between them, of course, we have the asteroid belt, which you can't really see here, but we're going to be zooming in. Yep, there we go. And we're going to be zooming into Jupiter, which is just a behemoth of a planet. So it's the most massive and largest planet. So it has more stuff than 318 Earths. So it would take 318 Earths worth of mass to make Jupiter, although you'd need different stuff because Jupiter is, of course, a different type of planet. It's a gas giant planet, meaning it's dominated by hydrogen and helium instead of rock like the Earth. So that's one thing that I really want to kind of get across is like, we're looking at this, what we're seeing is not painted on a surface, right? It is not a rocky, flat surface that you could stand on. This is gas and it actually has structure. So it's 3D. And it's this roiling atmosphere that we're observing here. It's not all at the same height. So you'll see this striping. So here on Earth, we have prevailing winds. But of course, this is gas. It's winds all the way down. And we have these kind of encircling what we call belts and zones. So the dark lines are what we call belts. And the light lines, regions and latitude that are lighter in color, those we call zones. And so this whole thing, all of Jupiter is, of course, rotating around its own axis, just like Earth does. So we've got a 24-hour day. Jupiter has about a 9-hour day, but actually it's not even the same length of time depending on where you would be in the clouds. So if you were at the pole of Jupiter, it would be a little bit longer than if you were at the equator of Jupiter. And so these bands and zones we see, you can kind of see some of the swirly, the fact that it's fluid, right? It's gas that's in this atmosphere. You can see spots which represent storms. The bands, the darker ones, are actually lower in altitude than the zones, which are the lighter ones. And I wonder if we can get a look at the largest storm on Jupiter, which has been raging at least as long as we've been looking at it. Humanity. We don't know how much earlier it was around, or even if it's going to stick around into the future, but everyone's heard of the Great Red Spot. So here we're looking at Jupiter lit up all the way around, and we're turning it around. You can see some of these smaller storms, and sometime soon we'll see our Great Red Spot come around.
It couldn't have gone too far. It's got to be.
There it is. Jupiter's really big. It takes a while to get around, right? So there it is. That is the Great Red Spot, which is a big storm in the atmosphere of Jupiter. It's bigger than Earth, and it has very fast winds in it, especially in the middle parts. So, and I love here you're getting a really good look at the turbulence in the atmosphere. So you kind of see these it looks like when you pour cream into your coffee, right? All of these swirls, all of these, we call them, fluid instabilities in the atmosphere, and they're just amazingly beautiful. And if you ever get a chance to see some other pictures, some higher resolution pictures from the Juno mission that we'll be talking about soon, I highly recommend looking those up because they're just amazing. It makes a great desktop background, just the swirls of Jupiter. You can't even tell it's Jupiter unless you know it. So Jupiter is an amazing planet, but another thing that makes it amazing is it has a ton of moons. So if we could show the video of all the orbits of all of the moons of Jupiter.
Oh, yeah.
So what? Yeah.
Yeah. So just so I usually say, I forgot to say a few quick words about OpenSpace. That this software is free. You can download it. I'm going to bring up a video that I recorded just a little bit earlier using the same software, the same OpenSpace software. You do want a solid graphics card, but again, all of this is real data that we just load into this amazing program, and it lets you fly around the whole universe in 3D. And tonight we're staying, again, kind of local, but just lots of really great data that we can show with this. So I'm just going to throw this little video up here and kind of play this coming in. I don't know if Jana can see this right now or not. Okay.
Oh yeah, I can't. Is it going now? All right.
Oh yeah. so just a whole mess of moons.
So you've got all the orbits of all the different moons. So Jupiter has actually 79 moons. At least those are the ones we know about. There's probably more. In fact, I'm not even sure that's the count for today, because we do have a probe that is looking in the vicinity of Jupiter and definitely has a possibility of discovering new moons. Most of them are little guys. And so they're either made of rock or ice, or a combination of rock and ice, and they're small. However, there are 4 big moons of Jupiter. So if you ever hear people talking about Jupiter has 4 moons, well, it's got 79, but most of them are smaller, much smaller. And then there's 4 ones that stick out for being much more massive than the rest. And we call those the Galilean moons. And we do that because Galileo was the first to see them through a telescope and realize that they were actually moons. They were moving around Jupiter. Irene was talking about observing the moons of Jupiter. And if you see Jupiter in the sky, if you're looking at Jupiter through a telescope or even binoculars, you'll see those moons. And you'll see them if you look over the course of a week or 2 weeks. You'll see them move, and those are the moons moving in orbit around Jupiter, those 4 big Galilean moons, which are the brightest guys. And so here we're looking at Jupiter's orbit, and we're going to go visit the first of these large moons called Io.
Right. Yeah, the other thing just about these 4 large ones that you noticed from this messy nest of a swarm, just all kinds of moons and all kinds of orbits. These four large ones, they're more well behaved, right? They're all like in a little plane there, so
Yeah.
kind of different.
Yeah. So basically, when Jupiter was forming, there was probably a disk. And out of that disk, we also had moons forming, kind of analogous in some ways to our whole solar system, because of when you were looking at the whole solar system, all the planets were in the same plane. But then you have other guys that had interactions. You might have had captured asteroids that became moons. And so those might have more erratic or less ordered, less in a plane orbits around Jupiter. And here it is. Here's Io. It kind of looks like an overdone pizza. It's pockmarked, and all of those pockmarks are volcanoes. So this is full of volcanic activity. It has active volcanoes, so they are erupting often. There's a really big one that was captured from Earth. A telescope on Earth was watching Io, saw this volcano called Tvashtar erupt. And the eruptions are so impressive because they go high above Io's surface for a variety of reasons. One, Io doesn't have it doesn't have an atmosphere. So you're not, so you're going up into very little, there's nothing really into space. And then the gravity of Io, because the mass is less than, for example, Earth. If you're thinking about volcanoes on Earth, the more familiar type that we see, since the gravity isn't pulling it down quite as much, it can reach these greater heights. And it'd be really amazing to kind of see this huge plume and all that material cooling very rapidly once it comes out and falling down to the surface of Io again.
That would get dangerous though, wouldn't it? Like you wouldn't want
Yeah,
to be
I wouldn't
like too
recommend.
close.
It'd be dangerous. You because it's so active, right? You'd have to be careful where you visit. And as you can see, there's very few places where it seems like it wouldn't potentially be affected by volcanism. And also the colors from all that sulfur. So I bet if you visited Io, of course you wouldn't smell it because you'd been in a spacesuit, but then when you went back inside your spacecraft, I bet it would smell of sulfur. I bet it wouldn't be very pleasant. But
Not your favorite.
yeah.
Do you
All
have
right.
a favorite moon of Jupiter?
Oh, I mean, I'm always partial to Europa, which is the next one we're going to talk about.
All right. Let's do that.
Yeah. So second orbit out, you can see there. Zooming in to Europa. So now the next three moons, those other three, are different from Io in that all of the three, the rest of those Galilean moons have oceans, which is really amazing. We think they're water oceans. They're not on the surface, though. You couldn't have water on the surface. It just couldn't, because of the physical conditions, survive, right? It would just freeze right away, which is what we're seeing. We're seeing the ice. So this is the icy surface of Europa, and it's thick. It's, maybe 20 kilometers. I don't know how many miles that is, right? But many miles of ice. And you'd have to get through that to get to that ocean. But underneath, the whole moon here has a water ocean underneath. We know it's salty water. We know that because the salt in the water means that it affects the magnetic field interactions between Jupiter and this moon. And that's something we can detect with probes. And you'll see here lots of cracking. So this is the ice surface cracking. You see that there's like a crater-like object. So you do get some cratering, but also this is upwelling and freezing. So we don't see as many craters as, for example, if you think about Earth's moon even, of course, that's a rocky surface. But here, that water is coming up and freezing, the surface is cracking, you have a lot going on. And we don't know what's in that ocean underneath. We have never, it'd be hard to get through that much ice, that thickness of ice, to get a probe in there. And you'd want to think about the implications of doing that, because there could be life in there. We don't know how sending a probe in there might affect things. This is a really special world. It's a special moon because of the possibility for life. And so it's a place of interest for sure for people who think about astrobiology and the possibility that, maybe there's fish down there, or maybe bacteria. We don't know. We wouldn't know if there were. So
Oh no, I gotta crack through a lot of ice and very
Yep.
carefully. A lot of ice.
Yep.
All right.
And so next we're going to go to the biggest of Jupiter's moons, Ganymede.
All right.
And this is similar to Europa in that it has this subsurface ocean again. And so what's really amazing is Europa, Ganymede, and Callisto individually, each of them have more water in their oceans than Earth has. And you could say, how can that possibly be true? These guys are smaller. They're much smaller than Earth, right? But our oceans are just this little veneer on the surface. It's just a little bit of water on top of a lot of rock. And these guys are a lot of ice, and underneath that, a lot of water. It's a worldwide ocean that goes all the way around. And so in there, contained within is more water than in all of the oceans of Earth.
So there's a lot of water in the solar system. Like we're not gonna
There is,
run
yeah.
out.
And it's interesting, right? Because there's a lot of water, but it's not in the same, it's not on the surface like it is on Earth. And so that's the difference, right? Is in these worlds we have ice. And so in the outer solar system we have lots more ice. We have hydrogen and helium, which was allowed to continue to exist and form into planets because it was colder out there. In the inner area, like Earth, for example, it was too warm and Earth is not massive enough to hold in, that it gets blown away. But that's why we have these big gassy planets with all of these moons, icy, rocky moons in the outer solar system. So there is Ganymede, our largest of the Galilean moons. And then last but not least, we'll be visiting Callisto.
Ooh,
Very
Callisto.
similar to Europa and Ganymede in that it has the subsurface ocean. Oh, I see the Pleiades in the background. You see the Orion's belt.
Oh, yeah.
We got some stargazing going on.
They're out there.
Mm-hmm.
Orion from Jupiter.
Yep.
The scene.
There we go. And there's the last of our Galilean moons, Callisto. And you can see there's evidence of impacts. A lot of it gets paved over on that ice, right? So if water comes up and freezes, it resurfaces, but you do get these pockmarks. There we go. This cratering, which is kind of revealing the layers underneath, which are a different color as that top layer.
Yeah, with all this cratering, this one almost reminds me more of like Mercury or the moon.
Yeah, it does look like that, but it's much icier than Mercury is, and it's of course got that ocean. So
More ocean than Mercury.
yes, yeah, yeah. Mercury, not much is going to survive there. Although they do think deep in those craters, you could have ice that somehow, even though Mercury is so close to the sun, survives in there. So, how do we know all of this stuff about Jupiter and its moons? Of course, we have observations here, here on Earth looking out, starting with Galileo's observations, but we also have sent probes. So we sent the Galileo probe, but most recently, in 2011, I think they launched the Juno probe, which is currently going around. It's orbiting Jupiter now. And so it is going around and around and around. I think it's 35 times it's planning to do 35 orbits of Jupiter. Oh, and here it is. Here's the Galileo spacecraft model. And so the next time when it's going to get the closest to Jupiter, so they call these perijoves. So perijove just means the point at which it gets closest to Jupiter. It's going around and around. The next one, you can mark it on your calendar, is July 25th. So you could have a party.
A perijove party.
Yeah, you could. I don't know, any excuse for a party. Although we're all doing Zoom parties these days, but but you can have a Zoom party. The only thing that's different about it, of course, is you get really good pictures, right? So all of this is paid for by taxpayer money, right? It's paid for by and that means that all the data that comes off of this through, NASA JPL, all of it is publicly available and you can get it for free. So all the raw data gets dumped off onto the internet and you can make pretty pictures. There's a lot of people that love making beautiful images of Jupiter's swirling clouds and things like that. And so there should be some good pictures coming out soon after July 25th if you want to see the new ones.
A post
So,
Perry Jove party.
post Peridot party, yeah. A lot of peas in there.
I like the Perry Jove. I mean, we talk about perihelion, but I think Perry Jove is that's just prettier somehow.
Yeah, well, my personal favorite, because it has to do with my research, is Paragalacticon, because it just sounds like it's quite a word, right?
You just made that up.
No, I didn't. No, but yeah,
All right.
it's
So
basically the closest point in any orbit. You put peri and then whatever relevant word
very
comes
close.
afterwards. Yeah.
So if you're like, the closest to your bedroom, it's like Perry that, like you're walking, pacing around your house or something.
Yep.
Okay, got it, got it. All right. Well, thank you so much, Jana, for sharing this with us, for sharing your excitement about Jupiter, even though apparently it's not your favorite planet. But but I
I'm never
forgive you.
gonna hear the end of that.
I forgive
Thanks
you.
for having me. Yeah, okay,
Yeah.
that's good.
So, do you want to tell us again, just remind people where they can see more lectures from Columbia?
Yeah, absolutely. So feel free to check us out. Our website is outreach.astro.columbia.edu. And we'll be adding new events as we have them. I think we're going to be doing one next Friday, actually, and it's going to be great. We have Professor Catherine Johnston speaking about the Milky Way and you. So it's going to be about galaxies and how galaxies are built up and what we can learn about the stars in our galaxy. So
All right. Well, I'll go ahead and try
join
and
us for that.
add that into the description on here, so if people want to come back and watch that, they can have that link. Um, Thank you again so much, Jana, for joining us. I'm just gonna throw up our credits again here. Again, we've been using Stellarium, which you can find at stellarium.org. Download that on your computer, your desktop, laptop, whatever devices. And then, of course, with all these beautiful views of Jupiter using the Digital Universe Atlas, using OpenSpace project to stream all of that. So you can find OpenSpace, download it for free at openspaceproject.com. I'm Irene Pease with the Amateur Astronomers Association of New York, and you can find us at aa.org. Thanks again for checking us out. Thanks for joining us for your Thursday evening dose of astronomy, and we'll see you next week.
Bye, everyone.